Hi students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing this chapter called as electrostatics. Let's start. We are doing numericals of electrostatics. A cube of marble, take down the sum please. A cube of marble having each side of length 5 meters, having each side of length 5 meters is kept in an electrostatic field of intensity 300 volts per meter, is kept in an electrostatic field of intensity 300 volts per meter. Determine the energy contained in the cube. Determine the energy contained in the cube if the dielectric constant is 8. Determine the energy contained in the cube if the dielectric constant is 8. Now, first of all, let's find out the energy stored per unit volume. Energy stored per unit volume. Energy stored per unit volume, U, is half epsilon 0 K E square. I know epsilon 0, I know K, I know E. Now, since the length of the cube is 5, it's a cube. Length of cube is 5 meters. Therefore, I can say volume V will be equal to L cube. Right? Once I know the volume, then I can find out the total energy. The total energy in the cube is going to be energy per unit volume into the volume. Energy per unit volume into volume will give you the total energy in the cube. The answer for this sum should be 3.982 into 10 raised to minus 4 joules. Next, take on next sum please. The energy density in a parallel plate capacitor, the energy density in a parallel plate capacitor, the energy density in a parallel plate capacitor is 2 into 10 raised to minus 8 joules per meter cube. 2 into 10 raised to minus 8 joules per meter cube. Find the electric field intensity in the region between the plates. Find the electric field intensity in the region between the plates when the medium is air. When the medium is air. Energy per unit volume, half epsilon 0 K E square. Therefore, you can say that E square is 2U upon epsilon 0 K. E is equal to square root of 2U upon epsilon 0 K. Right? You have U, you have K and epsilon 0. You can substitute and get the answer. The answer for this sum should be 67.23 newtons per coulomb. Next, take on next sum please. The plates of a parallel plate air capacitor, the plates of a parallel plate air capacitor have dimensions 0.01 meter. The plates of a parallel plate air capacitor, the plates of a parallel plate air capacitor The plates of a parallel plate air capacitor have dimensions 0.01 meter and 0.02 meters. If the plates are separated by a distance of 2.5 millimeter, if the plates are separated by a distance of 2.5 millimeter, calculate the capacitance of the capacitor. Calculate the capacitance of the capacitor. Calculate the capacitance of the capacitor. Now, I can say that area of the plate is nothing but length into breadth. They've given you the length, they've given you breadth. We know that epsilon 0 is 8.85 into 10 raised to minus 12 SI units. We had derived that capacitance is nothing but epsilon 0 A upon D. I know the distance between the plates, I know the area of the plates, I should be able to get the answer for this. The answer for this should be 7.082 into 10 raised to minus 13 farad. Right? Next, take down the next one please. Each plate of a parallel plate capacitor, each plate of a parallel plate capacitor has an area of 25 centimeters square. Has an area of 25 centimeters square. The distance between the plates is 0.5 millimeters. The distance between the plates is 0.5 millimeters. And the dielectric constant is 4. Find the capacitance. Find the capacitance of the condenser. Find the capacitance of the condenser. If a potential difference of 100 volts is applied to the plates of the condenser, find the electric intensity. Find the electric intensity between the plates and the charge on each plate. And the charge on each plate. Now, they've given you the area of the plates. So, first thing I can do is I can find out the capacitance. Capacitance is epsilon 0 K upon D. Here, since K is given to you, therefore I am using K. In the previous sum, the value of K was not given. That means it was assumed as 1, therefore I didn't use it. Here they have specifically told me that K is 4. So C is going to be epsilon 0 Ka upon D. Once I know the capacitance, then I can say that charge Q. No, they've given you the electric field intensity. First, let's find out the electric field intensity. Electric field intensity is nothing but potential difference upon D, and last charge Q is CV. So all the three things you can find out. C you have, potential difference is given to you. So the answer for this sum should be capacitance is going to be 17.7 into 10 raised to minus 11 farad. Electric intensity is going to be 2 into 10 raised to 5 volts per meter, and charge is going to be 1.77 into 10 raised to minus 8 coulombs. Next, take the next one please. A parallel plate condenser has circular plates. A parallel plate condenser has circular plates, each of diameter 20 centimeters. Each of diameter 20 centimeters, separated by a distance of 2 millimeters. If the potential difference between the plates is maintained at 360 volts, if the potential difference between the plates is maintained at 360 volt, calculate the capacitance and the charge. Also find the electric intensity. Nothing is given, that means K will be equal to 1. Very simple, similar to the previous sum. First of all, let's find out area. Now see, you have circular plates, so area will be nothing but pi r square. The area of each plate will be pi r square. Once I have the area, then I can find out the capacitance, that is epsilon 0 Ka upon d. So this is going to be nothing but epsilon 0 K pi r square upon d. That will give me the capacitance. Third thing they have asked you to find out is the charge. Charge is CV, potential difference is given, capacitance you will come to know from here. And last, they have asked you to find out the electric field intensity. That will be nothing but V upon D. So you apply the 4 formulas and you will get your answer. The answer for the sum should be, capacitance should come out to be 13.89 into 10 raised to minus 11 farad. Charge should be equal to 5 into 10 raised to minus 8 coulombs. And electric field intensity is 1.8 into 10 raised to 5 volts per meter. Fine, do we get this thing here? Next, let's see another sum. The capacitance of a parallel plate A capacitor, the capacitance of a parallel plate A capacitor is 10 picofarad. The capacitance of a parallel plate A capacitor is 10 picofarads. The plates are separated by a distance. The plates are separated by a distance of 1.4 millimeters. Next, find the radius of each plate of the capacitor. Find the radius of each plate of the capacitor if the plates are circular. Find the radius of each plate of the capacitor if the plates are circular. Since the plates are circular, I can say A is equal to pi r square, right? Next, they've said that capacitance is given to you. K is not given to you, so you can assume the value of K as 1. So C is equal to epsilon 0 A upon D. C is equal to epsilon 0 A pi r square upon D. So I can say that CD upon epsilon 0 pi is equal to r square. Therefore I can say R is CD upon epsilon 0 pi. You have C, you have D. Epsilon 0 we know is 8.85 into 10 raised to minus 12 SI units, where I can say epsilon 0 is 8.85 into 10 raised to minus 12 SI units. Pi is given to you, you should be able to get the answer for this. The answer for this should be, the radius is going to work out to, radius should be 0.02244 meters. That should be the radius of each plate. Next, take on next sum please. The outer diameter of the inner sphere, the outer diameter of the inner sphere and the inner diameter of the outer sphere are 9 centimeters and 10 centimeters. Are 9 centimeters and 10 centimeters. Find the capacitance. Find the capacitance if dielectric constant is 12. If dielectric constant is 12, if dielectric constant is 12, what will be the new capacitance? If dielectric constant is 12, what will be the new capacitance? If dielectric constant is 12, what will be the new capacitance? Right, I'm making a spherical capacitor. The inner radius is given to me, the outer radius is given to me. Right? That means, in that case, my capacitance, first of all, let's find out the area. How will I find out the area? I can say that capacitance for concentric is going to be, now capacitance is epsilon 0 A upon D, right? Now what will be the distance between these two plates? The distance between these two plates will be nothing but RO minus RI, right? D is going to be RO, outer radius minus inner radius will be the distance between the two plates, right? So in that case I know this, since they are circular, they are spherical, so in that case I can say that area is going to be nothing but spherical, 4 pi AB. For in the case of a spherical plate, this is going to be, it should be 4 pi outer diameter. It should actually be the area of the outer sphere minus the inner sphere. That will be the area that will be there for the each plate. So this, when you work this out, this will be 4 pi AB. When you work this out, you get this as 4 pi AB. So if I substitute these values, I'll get C
So
is
what area is
4 pi. Okay, I'll write this as this way. R0 into Ri. That'll be a simpler way of doing it.
But what, which part?
The capacitance due to inner sphere, top view, into the capacitance due to the outer sphere. Right? Generally we have two plates which are identical, so we take only one sphere. Here you have one sphere and there's another sphere which is of a different radii. So you'll have to take the capacitance due to both the spheres. Fine, do you get this thing
You're
here?
using that formula twice, right?
Which formula twice am I using?
Epsilon area by B.
Epsilon A.
I'll use, this was the general formula. Now I'm going to substitute here. Epsilon 0 A. A can be written as 4 pi R0 into Ri upon D. D can be written as R0 minus Ri. This was just the general formula I've written for a parallel plate capacitance when the radii of the two plates are same. But here the radii of the two plates are not same. So in that case, this is going to be epsilon 0 4 pi
So
R.
how you get 4 pi R0?
This it's spherical, so 4 pi, and that's how I will get this value, that 4 pi R0 into Ri. When I solve this, when I solve the two the surface area of the two spheres, the area of the two plates, if I see the top view, this is going to be circular, so that's how you will get this pi R, 4 pi R, multiply the two, you will get the total capacitance between them. Fine, do you get this signal? Now, let's see this. You will use the formula. So, what you have to remember is that when you have a hollow sphere, then it will be nothing but epsilon 0 4 pi, the product of the two radii divided by the difference between the two radii. Fine. So when you solve this, you will get this answer where we know that epsilon 0 is 8.85 into 10 raised to minus 12 SI units. Right? So when I solve this, this is going to be 4 pi epsilon 0 R1 into RO into Ri upon RO minus Ri. When you solve this, you should get this answer as 50 into 10 raised to minus 12 farad. Now the second part of the question is that if this space between the two plates is filled with a dielectric of 12, same thing, multiply by K. So in that case, if K is equal to 12, we had assumed K as 1, so C will be equal to epsilon 0 K 4 pi R0 Ri upon R0 minus Ri. So this will be 12 into whatever capacitance you found out, minus 12. You will get that answer, right? 12 5 is 60, 600 picofarads. Next, take on next one please. A cylindrical capacitor has two coaxial cylinders of length 0.12 meters and radii 1.1 centimeter and radii 1.1 centimeter and 1.2 centimeters. The outer cylinder is given a charge. The outer cylinder is given a charge of 2.5 microcoulombs. 2.5 microcoulombs. Find the capacitance. Find the capacitance and the potential on the inner sphere. Now capacitance of a cylindrical capacitor with air as dielectric is given by the formula C is equal to 2 pi epsilon 0 L upon 2.303 log of outer radius minus inner radius. That's going to be B upon A. That's your formula for capacitance, cylindrical capacitance. Like I gave you the formula for spherical capacitance. For spherical capacitance, it is the product of the two radii divided by the difference between the two radii. For cylindrical capacitance, it is 2 pi epsilon 0 L upon 2.303 log of B upon A. The division between the two radii, right? So when you solve this, you will get the capacitance of a cylindrical capacitance, whatever is your capacitor value. Now, they've given you that charge is given to you as 2.5 coulomb. Now, when a charge is given to the outer cylinder, the same charge will come on the inner cylinder. Due to capacitance, I can therefore say that charge on inner cylinder will be equal to same 2.5 into 10 raised to minus 6 coulombs, right? Once you have this, then I can say that once you have charge, then you can say Q is equal to Vc. They've asked me to find out the potential, so I can say V is equal to Q upon C. Q I know, C I would get from here. You should be able to get the answer for this. The answer for this sum should be capacitance should be equal to 7.668 into 10 raised to minus 11 farad, and potential difference should be equal to 3.26 into 10 raised to 4 volts. Right? Next, take on next one please. The gap between the plates, of a parallel plate A capacitor, the gap between the plates of a parallel plate A capacitor is half. The gap between the plates of a parallel plate A capacitor is half, and the area of each plate is tripled. And the area of each plate is tripled. Find the ratio of new capacitance to initial capacitance. Find the ratio of new capacitance to initial capacitance. Find the ratio of new capacitance to initial capacitance. Now, initial capacitance C1 is epsilon 0 A upon D, so A1 and D1, right? Final capacitance will be epsilon 0 A2 upon D2, but I can say that epsilon 0 A2 can be written as 3A1, D2 can be written as D1 upon 2, so this is epsilon 0 A1 upon D1. Denominator of denominator becomes numerator, so 3 2s are 6. They've asked you to find out the ratio of capacitance. That means they've asked you to find out C1 upon C2. So that will be nothing but epsilon 0 A1 upon D1 divided by 6 times epsilon 0 A1 upon D1. So C1 upon C2 is going to be 1 upon 6. Right? Take on next one please. A capacitor is filled with two dielectrics. A capacitor is filled with two dielectrics having the same dimensions and constants K1 and K2. Yeah. A capacitor is filled with two dielectrics of same dimensions and dielectrics K1 and K2. What is the effective capacitance if K1 is 3 and K2 is 5? The area of each plate is 2 into 10 raised to minus 4 meters square, and the separation between the plates is 4 millimeters. And the separation between the plates is 4 millimeters. Now C1, let's assume since there are two dielectrics, there will be two different capacitance that will be formed between them. I can say that C1 will be nothing but epsilon 0 K1A upon D1. C2 will be epsilon 0 K2A upon D2. Right? Now C1 and C2, this will be the capacitance C1 and this will be your capacitance C2. So C1 and C2 here are in series, but I can say C1 and C2 are in series. Since they are in series, their equivalent capacitance will be CS, and I can say 1 upon CS will be nothing but 1 upon C1 plus 1 upon C2, right? In which case I can say that 1 upon CS is 1 upon C1, that means epsilon 0 K1A upon D1 plus 1 upon C2, that is epsilon 0 K2A upon D2. Here I can say 1 upon CS is 1 upon epsilon 0 A common, so that will give you D1 upon K1 plus D2 upon K2. But they have said that the two dielectrics have same dimensions. As the two dielectrics have same dimensions, therefore K1 should be equal, D1 should be equal to D2 should be equal to D. So if I substitute, I'll get 1 upon CS is 1 upon epsilon 0 A D upon K1 plus D upon K2. D I can remove common outside, so I'll get this as D upon epsilon 0 A is 1 upon K1 plus 1 upon K2, right? If I simplify this, then I'll get this as, reciprocate this. If you reciprocate this, you will get this as CS is equal to epsilon 0 A upon D K1 K2 upon K1 plus K2, K1 K2 upon K1 plus K2. So out of these I have all the values. Now if the total length is 4, that means this I can say where D1 which is equal to D2, same dimensions. Now the total length, guys, the total length is given to you as 4 millimeters. If it is divided into two parts, that means each part will be 2 millimeters. Therefore D I can say is 2 millimeters, 2 into 10 raised to minus 3 meters, right? You will get D is equal to 2 into 10 raised to minus 3 meters. Epsilon 0 we know is 8.85 into 10 raised to minus 12 SI units. K1, K2, we know the value of K1, K2. Yes, I should be able to get the value of capacitance in series. Answer for this should be 1.66 into 10 raised to minus 12 farad. This is assuming that the capacitance are connected in series. I could have also done the same thing. You could get a question like this where they could say that the capacitance is in parallel, so you would use the parallel formula, right? If for that the diagram would have been this way.
So what value will you get for K1 and K2?
K1 is 3, K2 is 5. K1, K2, and they could have said that you have a capacitor like this, in which case then the capacitance would have been in parallel and you would have done the same way, except that you would have used the parallel formula, right? Do we get this thing clear? Okay, we'll stop this here for the day. Thank you very much.